In this video, we will discuss angles and arcs within circles. A central angle of a circle is an angle with a vertex in the center of the circle. So if we look at ABC, has vertex B, ABC is going to be, this angle here is a central angle of circle B. Its sides contains two radii, so this radius here and the radius here are the sides of the angle. A degree is 1 divided by 360 of the circular rotation about a point. So if we have a circle, right, it's going to go 360 degrees total. So think about if you were to turn around 360 degrees, you would form a full circle. So there's 360 total internal degrees in a circle. That brings us to the sum of central angles. So the sum of central angles is always going to be 360 degrees. So if we have angle 1, 2, and 3 here, we add them all up, we're going to get 360 degrees. All right, let's take a look at an example of how to apply this. So this question tells us to find x. So we have a 130 degree angle here, a 90 degree angle here, and then the last one we're missing is the x. But we know that every circle, the central angles are going to add up to 360. So we can say 130 plus 90 plus x equals 360. So we're going to subtract 130. On both sides, subtract 90 on both sides. So x equals 360 minus 130 minus 90. So x is going to equal 140. All right, so now we're going to take a look at arcs. An arc is a portion of the circle defined by two endpoints. A central angle separates the circle into two arcs with measures related to the measure of the central angle. So if we have central angle here, it's related to this arc between endpoints P and R. And so what we know about arc measures is that a minor arc is the shortest one. So this one here is the shorter one that we just looked at. So that's going to be the minor arc. So it's the shortest arc connecting the two endpoints of a circle. So a minor arc, since it's going to be the shorter one, is going to have a measure less than 180 degrees and equal to the measure of its related central angle. So arc AB is going to have the degree measure of x degrees. A major arc is the other side, so that's the longer side that's left over. So if we look up here, I'll do this part in red. Oops. So if we look up here, this part, this arc, is the major arc. It's the longest arc connecting two endpoints on a circle. So the measure of the major arc is going to be greater than 180, and it's going to be equal to 360 minus whatever the minor arc was. So ADB here is going to equal 360 minus the minor arc AB. Lastly, we have a semicircle. So a semicircle is an arc with endpoints that lie on the diameter. So if the endpoints lie on the diameter, that means it splits the circle into two equal parts. So two equal parts, if we have a total of 360 degrees, 360 divided by 2, the measure is just going to be 180. So each arc in a semicircle is going to be equal to 180 degrees. Let's look at an example of how to apply this. So it tells us that GJ is a diameter. Let me add it here. Gj is a diameter of circle K. We want to identify each arc as a major arc, minor arc, or semicircle. So here is our diameter. If we want to look at GH, so GH is 122 degrees. We want to find its measure too. Because it's less than 180, it's not quite the semicircle, it's the smaller part, it's going to be minor. So GH is a minor arc, and it's equal to 122. Now let's look at GLH. So GLH, so it has endpoints that are the diameter, G and J. Oops, sorry, I'm looking at GLJ right here. GLJ has endpoints that are the diameter, right? So that means it's half the circle, or 180 degrees, which makes it a semicircle. Now let's look at GLH. So GLH goes all the way over here. So GLH is the bigger portion, so it's more than the semicircle, greater than 180 degrees. So it's going to be our 360, the entire circle, minus this part here. So minus 122, and that gives us 238. And because its degrees are greater than 180, it's going to be considered a major arc. Now let's look at congruent arcs. So congruent arcs are in the same or congruent circles, and they have the same measure. Oops. All right, so in the same circle or in congruent circles, two minor arcs are congruent. So it has to be either in the same circle or equal circles, congruent circles, if and only if their central angles are congruent. So the if and only if tells us that if the two angles are equal, then the arcs are congruent, or if we know the two arcs are congruent, then we know the central angles are also congruent. So it goes both ways. That's what the if and only if means. So let's apply this. So find arc measures in circle graphs. Refer to the circle graph. Find measure of CD. So we want to find the measure here. Edit. We want to find the measure of CD. So we want to find this measure right here. And it tells us that this is 18% here. So it's 18% of the entire circle. We know that a whole circle has 360 degrees. So if we want to find the portion that is 18% of the total of 360 degrees, what we can do is we can just say 0.18. So 18% as a decimal is 0.18. So 18% of, so of means multiplication of 360 equals, and that equals our measure of CD, which is equal to the measure of the arc length as well. So 0.18 times 360, we get 64.8. Lastly, for this lesson, we're going to talk about adjacent arcs. So adjacent arcs, like adjacent angles, are right next to each other. They share exactly 1 point in common. So HJ and HJ and KJ share this point right here in common. So in circle M, HJ and JK are adjacent arcs. As with adjacent angles, you can add the measures of adjacent arcs. And when we add the measures of adjacent arcs, the sum of the measures is going to give us the bigger arc. So the arc formed by two adjacent arcs is the sum of the measures of the two smaller arcs. So the XYZ would be the sum of YZ and XY. Now we want to find the measure of AED in circle F. So if we want to find the measure of AED, so AE and DE are adjacent arcs. We know AE is 63, and the measure of DE is 90. So AED, we can just add the two adjacent arcs to each other. So we're going to add 63 plus our 90 plus 90 equals 153. So our measure of arc AED equals 153.